Wait, hang on. Okay.
Hi there. I'm Hunter Mollet.
I am Paul Kellerman.
And I'm Zane Brainerd.
For our MIME 101 team project presentation, we are presenting the Laurel fan. In our product selection and our functional analysis, the Laurel fan is a 6-inch fan with 2 speeds, a 5-inch cord. It is 5-foot cord. It is 8 inches by 6 inches by 9.5 inches. It's colored white, and it's mainly used as a desk fan that clips on to the desk it is being used on. It's meant for homes and offices mostly, and our functional decomposition, we found its main inputs were electricity and air, with a byproduct of heat caused by when the electricity is used to turn the shaft within it. And its main outputs are air and a byproduct of noise when the air is pulled through the blades of the fan itself. In our exploded view, it's made up of a couple of main parts, with the motor section being the most complicated. And we determined that it was fairly easy to manufacture and mass produce from its design.
In this next slide, we've got our Tinkercad designs of the different pieces that we individually created. On the left, there is the middle shaft that the fan attaches to that goes straight through the middle of the motor and the part that spins. In the middle, we have the back plate where the switch would connect to, and it closes the back of the basket to keep all the electronics concealed. On the right, we have a switch that we created as well. On our bill of materials, we have 10 screws that are made of steel that are thread rolling. We got the front basket that is made of plastic and is injection molded, the back basket that is also plastic and injection molded, the fan blade and the wire harness, both which are plastic, both of which are injection molded, the motor block, which is steel from steel making, the cylinder cap, we have 2 of those, and those are steel from steel making. There's the motor shaft also that is steel and from steel making. We have internal wires. We have a total of 4 of them. We also have 1 external wire. They are both copper and both wire drawing. Lastly, we have the back plate and the switch, which are both plastic and injection molded.
So the material properties of the fan blade is the fan blade of the fan is the fan, like it pulls through air through the back, so it pulls it through colder air and pushes out the front. The part is made of plastic. The fan blade is ductile, which is retaining its shape easily, the stress of the spinning motion while resisting bending, cutting through the air. It's cheap and light, and it's able to handle the forces put upon it without failing. This is the engineering design map we made. So it kind of labels the part life of it, and it starts with the design phase, and it then moves to the material gathering phase, where the materials are taken out of the earth or made, the raw materials, and then it moves to the manufacturing phase, which is the fan actually being assembled in the factory. And one of our suggestions was that it could be made greener there, just as a general. And then the next phase is the packing and distribution. This is there was a lot of packing material that we could cut down the packing materials or use biodegradable ones. So, and then the final or the next one is the product use. We said that this phase could be made greener for the user, so you don't have to use electricity all the time. So, and then finally, at the end of the product's life, it goes into probably a landfill or something of that sort. Thank you for watching. And that is the end of our video. And this is our team charter for our group.
We missed the